Hi, welcome to Learning Monkey. I am Raghu here. In this class we will discuss about finding the median in a given stream of elements. So the explanation is completely based on the assumption that you already have some basic coding knowledge. If you are not good at basic coding, please watch our website learningmonkey.in, take the course placement training for service based companies. Then come for the competitive coding. Coming to today's class, so given an input stream, means a stream of input is coming. So find the median for each input element. Whenever you got a new input element, we need to identify the median value. A new element comes, you need to identify a median value. So you have to maintain a time complexity of order of NlogN and space complexity of order of n. So coming to the with example, you are going to understand better. Here the stream of elements, 4 elements has been given, but it has given in an array, but assume it's coming in a stream, means the first element we got is 5, next element is 15, next element is 1, next element is 3. So whenever you got the 5, you have to display 5. Median of 5 is 5. Whenever next input has come, 15, 5, 15, what is the median value? If 2 elements are there, even number of elements are there, median is 5 plus 15 by 2, which is 10. If you got the next element 1, you have to arrange them in ascending order. 5, 15, 1. If you arrange them in ascending order, 1, 5, 15. What is the middle element? 5. That is what the median here is. 5 is the median value. Coming to the next input, 5, 15, 1, 3 has come. Arrange them in ascending order. 1, 3, 5, 15. What is the middle elements? If even number of elements, middle element is not there. That's why we consider the middle 2 elements. 3 plus 5 by 2, which is 4. Our output is 4. Median value is 4 value. This is what we need to display. We need to display 5, 10, 5, 4. That's the output we have to display. So you have to maintain the time complexity of order of NlogN. That is very important to understand. But they have mentioned that they are going to provide you 3 functions. Given 3 functions: insert heap, balance heap, find median. They already given the idea that you have to maintain a heap data structure. So insert heap function, balance heap function, and find median function. We have to fulfill this. We have to write code for all these 3 functions. Coming to the logic part, see, let's take, without using heap also we can do this example. 5, 15, if already these elements are there, if new element has come 1, arrange the elements in ascending order using insertion sort. Insertion sort is very suitable in this situation. 5, 15, 1 has come, check back until this position, until where the 1 is, the best position for 1 is. That is what insertion sort, that is how insertion sort works. But if you use this technique, insertion sort, it is going to take a time complexity of order of n square. It is given that you have to maintain a time complexity of order of NlogN. How to do that? So we will show you different examples here, but understand it properly. It's a bit complex to understand, but if you complete this example, you will get a good idea about heap data structure, how, in which situations we go with heap data structure. All these things you will get clarity. If you don't understand with one time watch, go watch multiple times until you get clarity. So let's come to the example first. Assume that the elements are 18, 45, 95, 132, 165, 209. Elements are in ascending order. If this is the situation, here even number of elements are there. Our motto here is we have to divide this entire elements. Forget about this 100 in between. We don't have that element 100 as of now in this example. 18, 45, 95, 132, 165, 209. 6 elements are there. We have to divide them into 2 halves. Left half, right half. So left half elements, you maintain a max heap data structure on left side. Right half elements, you maintain a min heap data structure for the elements present on the right side. So whenever you maintain max heap on the left side, what's the meaning of that? Max heap means the topmost element is the maximum element that present on the left side. And if you consider min heap on the right hand side, topmost element is the minimum element that present on the right hand side. equal number of elements, same number of elements on the left and right. So the median is 95 plus 132 by 2. Same number of elements left and right side. So median is 95 plus 132 by 2. So in order to find the median, we are having only two cases: even number of numbers or odd number of numbers. If you are having odd number of numbers, so let's take the situation 18, 45, 95, in between 100 is there 132, 165, 209. So if you maintain a left half, 100, 95, 18, 45, 4 elements comes to left half, 3 elements comes to right half, 132, 165, 209. Left half means max heap, right half means min heap. So left half is having 1 element more when compared to right half. So what is the median value? This is the median value. 100 is the median value. If right half is having 1 element more when compared to left half, what is the median value? The topmost element on the right side is the median value. This is what we are going to use. So always maintain two heaps, left half, right half. Left half max heap, right half min heap we have to maintain. But conditions, see, you have to understand, either you have to have equal number of elements, or you should have any one side 1 element more when compared to the other side. That is what we need to maintain. How we need to maintain, what are the conditions to maintain, that we are going to understand now. Suppose let's take our next element. Suppose for the same data structure, for these elements, 3 elements, if a new element has come 148, the first thing we are going to do is insert, heap, push this element onto the left half. Means it is going to execute max heap. 148 is inserted onto this left half. Then the elements will be like this: 148, 95, 45, 18. And the right half is as it is. Now we have to compare 148 with 132. 148 greater than 132. What's the meaning of that? 148 greater than 132. What's the meaning for that? See, 148 greater than 132 means this 148, whatever the new element 148, it should belongs to the right side. It should belong to the right side, because this is the minimum element that we got on the right side. So this 148 should be this side. So that's why when this condition satisfies, take out this 148, the remaining heap is like this: 95, 18, 45, and 148 should be sent to the right side. Then 132, 148, 165, 209 means heap push onto the right hand side. Now elements are in, this is 95, 132. Which side we are having more elements? 1 element should be more when compared to the left side. 132 is the middle element. That is what the median value. So this is what we are doing. Whenever you got a new element, push on to the left side. Compare this with the right hand side. If it is greater, means this element belongs to the right side. Push on to the right side. Take out means pop from this, heap pop from this and push on to the here. So one more condition you have to understand. So number of elements right side greater than number of elements on left. So median is 132. See, if you for better understanding, we have written this in ascending order: 18, 45, 95, 132, 148, 168, 165, 209. So what is the middle value? 132. Now take one more element. Next element is 180. For the above heap, this is the heap we remind with in the previous example. If you got a new element 180 should be pushed onto the left hand side. Whenever you push this element onto the left hand side, this is the max heap we got it: 180, 95, 18, 45. 180 should be checked with 132. 180 is greater than 132 means this element should belongs to this heap. Okay, so take it and push on to this. Whenever if you push 95, 18, 45, 132, 148, 165, 180, 209. See the condition here. This side 3 elements are there, this side 5 elements are there. But we need to maintain equal number of elements or one element greater when compared to other side. But here 2 elements greater when compared to other side. So take out this 132 and share it with the other hand. These are the conditions you have to set. You have to write in the coding. Always maintain 2 halves equal or one element greater when compared to the other side. Here we are having two elements. If left hand side is having 2 elements greater when compared to the right hand side, take one element, the topmost element, and push on to the right hand side. This is what the benefit of heap. Left side always the elements are less when compared to 95. Right side always elements are greater when compared to 132. So these two will be the median values, middle values. Remaining goes to the other side. You got an idea, right? That is what we are doing. So length of right minus length of left greater than 1. So send 132 onto the left hand side. After sending 132, 95, 45, 18, 148, 165, 209, 180. Equal number of elements. Whenever you are having equal number of elements on the left and right, what's the condition you have to apply? 132 plus 148 by 2 is the median value. These are the conditions you have to mention. So with this understanding, you try to identify, you take different examples and try to identify the different condition, identify the conditions once again and try to write the code on your own. That is the best practice. Anyhow, we are going to explain we are going to give some hint on the coding also. In our last videos, we discussed heap queue data structure, which is available in Python. In our previous examples, when we discussed about kth largest element or the merging to k linked list, we used a heap class already available in our Python, heap queue class. It is used to identify, you maintain a min heap data structure. But coming to the point here, one side we have to maintain max heap, on the other side we have to maintain min heap. With the same class we are going to do both the things. How we are going to do both the things? So we are going to use heap queue. So if you want to maintain max heap on the left hand side, convert the numbers into negative numbers. Apply min heap. You are going to get the max heap. That is the condition we are going to use in our example. Negative numbers, apply negative sign to the numbers on the left hand side and apply min heap. The element that comes up is the maximum element. Whenever you popping it, apply again minus. That is how we are maintaining max heap using min heap. So coming to the logic, see, balance heap. If you have to check the conditions, self dot small of 0 means first element, topmost element, self dot large of, here we are taking 2, self dot small and self dot large are 2 lists in order to maintain left side max heap and right side min heap. The first condition is if 0 greater than self dot small of 0 means left side 0th element compared with the right side 0th element. If it is greater, what we have to do? Pop the element from the left side and push on to the right side. And after that we have to check the conditions. Length of the elements, length of the elements means number of elements on the left side and number of elements on the right side should be equal or greater than, at least one element greater than. That is the condition. This is if, else if. These are the two conditions. This is what the balance condition. And coming to the get median value is very easy. If length of left side is greater than length of right side, display the left side element, topmost element. If length of left side is less than right side, display the right side element, topmost element. Otherwise, do the median value, both topmost elements, add it and divide by 2. Now coming to the insert heap of what we are doing. Initially we are pushing the element, the new element is going to push on to the left hand side. So self dot small, negative value, see minus x. We are converting it to minus x and pushing on to the max heap. Then call the balance heaps. Balance heaps is going to check the conditions or 3 conditions are there. Those conditions will be checked there and it is going to balance the heap. So hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.